Namaskar friends, I welcome you all in this class of mathematics. In the last class we discussed fundamental principles of counting, in which we discussed the two things: fundamental principle of multiplication and fundamental principle of addition, FPM and FPA. And we also discussed about factorial. So, today we are going to discuss permutation, and all the three concepts we discussed last time is going to be used today. It is a quite interesting subject, interesting topic, permutation. It is a very good and interesting branch of mathematics, which is also related to art and aesthetics. You see how the things can be arranged in how many manner. The study of these things we do in permutation. So, arrangement of things, basically two types. One is linear permutation, and other one is circular permutation. So, let us discuss first the linear permutation. When things are there in a line, in one straight line, and then we study the arrangement of the things, is called linear permutation. Suppose there are n number of things, n things, and all n things are distinct. Distinct means no two things are same. Then in how many ways their arrangements can be done. So, you see the formula is, we denote is by n p n. What does this n means? That there are n things, p means their arrangement, permutation, taking n things at a time. So, rather I should write a general formula, NPR, then the formula is factorial n divided by factorial n minus r. So, you see last time we studied factorial and we are going to use here. Now, we can verify this formula. Suppose there are two things, say A and B. So, this can be arranged in two ways, A B and B A, isn't it? So, this is 2 P 2 is equal to factorial 2 divided by factorial 2 minus 2 is equal to factorial 2 divided by factorial 0, and you know factorial 0 is equal to 1. So, it will be equal to 2. Now, suppose instead of 2 there are 3 things. Say 3 lights are there, red and yellow and green. So, how many permutations are possible? So, the possible arrangement is, let us take R at first place, R, then yellow Y and then G green. The other one R, and we can change their place, G Y. The fourth one, let us take Y first, remaining will be R and G. So, Y R G, and then taking Y at first place, let us change their place, Y G R. Again taking G at the first place, so G R and Y, and then G Y and R. So, these are 6 arrangements possible according to formula. 3 P 3 will be equal to factorial 3 divided by factorial 3 minus 3 is equal to factorial 3 divided by factorial 0 is equal to factorial 3 divided by 1. As you know, factorial 0 last time we discussed, it is equal to 1. So, this will be equal to 3 into 2 is equal to 6. So, you can verify how this has come. Now, let us take another example. It is not necessary that we always take all the things at a time. So, suppose 4 things are there: A, B, C and D. Now, taking one at a time, so 4 P1 is equal to factorial 4 divided by factorial 4 minus 1 is equal to factorial 4 by factorial 3. So, this will be equal to 4 into 3 into 2 into 1, we can write it factorial 3 and here also factorial 3. So, this will be cancelled out. So, it will be equal to 4. It is easy to visualize that the 4 things you can select taking one at a time. So, A, B, C and D. So, if you select only one thing out of the 4, one time you can select A, other time you can select B, other time you can select C and then D. So, there are 4 ways in which you can select one thing out of 4. Now, suppose we have to take 2 things at a time, okay. Say 4 P2. So, this will be equal to factorial 4 divided by factorial 4 minus 2 is equal to factorial 4 divided by factorial 2 is equal to 4 into 3 into 2 into 1, which we can write factorial 2 divided by factorial 2. So, these will be cancelled out. So, there will be 12 ways. Let us see what are these 12 ways. So, we are taking 2 at a time. So, we can take A and B. Now, other 2 can be A and C. Other 2 can be A and D. Then starting from B, other 2 can be B and C, and then B and D, and then last combination C and D. Now, if A and B is here, so B and A will also be an arrangement. You just reverse their position. So, it will be A and C is there. So, C and A, C A will another arrangement. A D, then D A will another arrangement. B C, then C B is another arrangement, and B D, then D B another arrangement, C D, then D C will be another arrangement. So, how many arrangements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, there are 12 arrangements. So, you can visualize that if you are taking 4 out of 2 things at a time out of 4 things, there are 12 number of arrangements. Now, let us take three things at a time. Say let us see by formula how many will be there. So, 4p3 taking 3 at a time will be equal to factorial 4 divided by factorial 4 minus 3. So, factorial 4 factorial 1, factorial 1 is also equal to 1. So, it will be equal to 4 into 3 into 2, which is equal to 24. Now, in how many ways? You just visualize. Let us take A, B, C. Okay. Another combination can be A, C, D. Okay. Then another combination can be B, C, D. Now, with combination A, B, C, how many can we make? A, C, B, another arrangement. Then we can make, let us take B first, B, A, C, and then B, C, A. Then taking C first, C, A, B, and then C, B, A. So, you can see 1, 2, 3, 4, 5, 6. 6 permutation is possible with A, B, C, 3. Again 6 is possible with this. Let us write it quickly. A, D, C, then sorry, B is not here. We are A, C, D. So, then C, A, D, and then C, D, A, then D, A, C, and D, C, A. These will be another 6. Now, here also B, C, D, then B, D, C, then C will come first, C, B, D, then C, D, B, then D, B, C, and D, C, B. So, these are the 6 permutation. And then one more combination is missing here, that is we have taken A, B, C, then A, C, D, and then B, C, D. Yes, A, B, D. A, B, D is missing here. So, if I take A, B, D, again 6 will come here, A, B, D. So, A, D, B, then B, A, D, and B, D, A, then D, A, B, and D, B, A. So, you can see here that this constitutes 24. Now, if I take similarly, if I take 4 all A, B, C, D 4 at a time, so this will be equal to 4 P 4, which is equal to 4 factorial 4 divided by factorial 4 minus 4, which is equal to factorial 0, which is equal to 1, factorial 4 divided by 1. So, this will also become 24. So, I now leave this for you as an exercise. Do not go by formula, just I have mentioned here, you write all the combinations, all the permutations A comprising A, B, C, D. So, A, B, C, D is just one, then what are the other permutation, say A, B, D, C will be another, then A, C, B, D will be one, then A, C, D, B will be another. So, similarly, you will find out 24 permutations. So, friends, this is a good exercise for brain, and I will say that you should do that, because unless you use the faculty of your brain, its exercise will not be done. And regarding the body parts, that if you do not do exercise of a part, that it will become weak. So, if you do not want that your brain should be weak, then you should do some exercise, and this permutation and this whole even solving any new mathematics is very much enjoying, and it exercises your brain. So, it keeps it in good health. So, let us take an example here. Suppose the problem is that find n if 5pn is equal to 6pn minus m. It is given 5pn is equal to 6pn minus 1. Okay. Let us solve it. So, this will give, according to formula, factorial 5 divided by factorial 5 minus n will be equal to factorial 6 divided by factorial 6 minus n minus 1. So, this will be equal to factorial 5 divided by factorial 5 minus n is equal to factorial 6, and this will be equal to factorial 7 minus n, because this, if you open bracket, this minus minus will plus 6 plus 1 7, 7 minus n. So, let us bring 7 minus n this side, 7 minus n divided by factorial 5 minus n, and take factorial 5 this side. So, this will be equal to say factorial 6 by factorial 5. Now, this will give, let us factorize it, 7 minus n, then the next term will be minus 1. So, it will become 6 minus n, and the next term will be 5 minus n, and it goes till 1. So, we can write it factorial 5 minus n, isn't it? You just remember the definition of factorial, and this is factorial 5 minus n is equal to, it is 6 into factorial 5 divided by factorial 5. So, since all multiplication is there, so we can cancel out this here, it will become 1, and this with this here also it will become 1. So, this will be 7 minus n into 6 minus n will be equal to 6. So, now this is a simple quadratic equation we have to solve, and you can solve it easily. It will be equal to 42 minus 6 n minus 7 n. So, minus 13 n plus n square. Let us bring 6 to this side also, minus 6 is equal to 0. So, this will give n square minus 13 n, 42 minus 6 will be equal to 36. Now, from here you can calculate the value of n. N will be equal to, you know the formula, minus b. So, it will be 13 plus minus under root b square. 13 square is 169 minus 4 AC, 4 into 36 divided by 2. So, it is equal to 13 plus minus, this will become 144. So, 160 minus 69 minus 144 is equal to 25. So, plus minus under root 25, it means 5 divided by 2. So, it is equal to 13 plus 5 is equal to 18 divided to 9, and 13 minus 5 is 8 divided by 2 is equal to 4. So, we have found out the value of n will be, because the question was find n. So, n is equal to either 9 or 4, but if we take n is equal to 9, this is 5 p n. So, 5 p n will become 5 p 9, but this is not possible, you know, because you cannot take 9 things for arrangement out of 5 things. So, this is not possible. So, only possible value is n is equal to 4. So, this equation, given equation will be true only if n is equal to 4. Let us quickly take one more example. The problem is that there are flags of 4 colors. So, how many signals can be made out of these 4 color flags taking any number of time, any number of flags. So, how many signals are possible? Signals are possible with 4 flags of different colors. With 4 flags of different colors. Now, very easily it can be solved. Suppose signals may be of one flag only. So, only one flag, so there are 4 colors. So, it will be equal to 4 p 1, which is equal to factorial 4 divided by factorial 3 is equal to 4, because equal to 4 multiplied to factorial 3 will cancel out. So, it will become 4. Very simple, four color flags. So, taking one at a time, it will become 4. One flag will go to 4. Suppose taking 2 flag at a time. So, this will be equal to 4 P2. As we have seen that out of A, B, C, D, we took the combination of 2. So, it became 24. By writing formula, it will be equal to factorial 4 divided by factorial 4 minus 2. So, it will be 4 into 3 and factorial 2 will go. So, it will be 12, not 24, it will be 12. Now, taking 3 flags at a time, so this will be equal to 4 P3 is equal to factorial 4 divided by factorial 4 minus 3, which is equal to factorial 1, which will be equal to 1. So, this will be equal to 4 into 3 into 2, which is equal to 24. Now, taking all the flags, 4 flags at a time, this will be equal to 4 P4, which is equal to factorial 4 divided by factorial 4 minus 4. It means factorial 0, which is equal to 1. So, this will also become 4 into 3 into 2 into 1, which is equal to 24. So, with fundamental principle of addition FPA, you can make signal with 1 flag, which is equal to 4. You can make signal with 2 flags, which is equal to 12. Make signal with 3 flags, which is equal to 24. So, we will add all this and then signals with 4 flags, which also be equal to 24. So, this will be equal to 48, 60, 64. This will be equal to 64. So, it is quite interesting mathematics. Now, let us take permutation when the things are not distinct, all the things are not distinct, then how do we solve? So, let us say permutation when things are not distinct. Say there are n1 things of say first type, n2 things are second type, n3 things are third type, and similarly nk things of kth type. Here what is required? There are n number of things. So, n1 plus n2 plus n3 nk is equal to n, and ni is greater than equal to 1, and I varies from 1 to k. So, the formula for this is, suppose if all were distinct, then formula would have been factorial n, but since all are not distinct, so because it would have been factorial n divided by factorial n minus n, that is factorial 0, that is equal to 1. But since there are different types, not all distinct, so this formula becomes factorial n1 into factorial n2 till factorial nk. So, this is the formula. Now, let us take an example so that it will be clear to you that how it works. You just remember this formula. Here n1 of one type, n2 are of another type, and similarly there are k types nk. So, let us take an example. Suppose this word is there, a Alpana. Six letter word, 1, 2, 3, 4, 5, 6. So, with these 6 letters, how many words can be made? If all the letters are distinct, such as, let us take another example, equation. All the letters are distinct, 1, 2, 3, 4, 5, 6, 7, 8. So, how many 8 lateral vaults can be made, meaningless or not meaningless? So, this will be equal to 8p8, which will be equal to factorial 8. But in this case, alpna, all letters are not distinct. How many A's are there? A's are 1, 2, 3. 3 A's are there, and then L is there, which is 1. P is there, which is 1, and N is there, which is 1. So, according to formula, the 6 letter meaningless or non-meaningless number of words will be equal to factorial 6 divided by factorial 3, and all these factorial 1, which is equal to 1, factorial 1 into factorial 1 into factorial 1. So, basically it is equal to factorial 6 divided by factorial 3, which is equal to 6 into 5 into 4 into factorial 3 divided by factorial 3. So, this will be cancelled out. So, it will be equal to 120. Now, suppose in place of alpna, I take another example, banana. One, two, three, four, five, again 6 letter word. Here A is again 3, and then B is 1, N is 2, so according to this formula, the number of 6 letter words will be equal to factorial 6 divided by factorial 3 into factorial 2 into factorial 1, which will be 6 into 5 into 4 into, it will be factorial 3, and here factorial 3 into factorial 2. So, this will be cancelled out. So, this will be equal to 60. So, suppose, let us take one more thing. Suppose repetition is allowed, then what is the formula? there are suppose n things are there, and repetition is allowed, say A, B, C, 3 letters are there, and it is said that form the 3 letter word, then how many words are possible? So, if the all distinct letter is allowed, then you know we have find out that it will be equal to A, B, C, then A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. 6 permutation is possible, but if repetition is allowed, 3 letter words out of these 3, so then A will also come here, B will also come here, C, sorry, C will also come here, and similarly B, isn't it? A. So, the simple formula for it that there are 3 letters and you have to make 3 letter word. So, first place you can put 3 places are there. Here you can either put A or B or C. So, it can be filled up in 3 ways. This also repetition is allowed. So, this can be also filled up by in 3 ways, and this place can also be filled up by 3 ways. So, according to the fundamental principle of multiplication, the number of permutation will be equal to 3 into 3 into 3, which is equal to 27. So, if there are n things out of which r things are to be arranged, so and repetition is allowed, then NPR becomes n to the power r, where r is greater than equal to 1 and less than equal to n. So, let us take so next time we will take an example on this, and we will also cover the circular permutation. So, today we covered linear permutation, and next time we will cover circular permutation and then combination. So, friends, I hope you have understood. It is quite interesting, and you go through the problems on it, so that you can ask some questions next time. Thank you.